Welcome to this Fundamentals of Cybersecurity class. So we have started the Unit 2, right? The CO2 of the Unit 2 is, course outcome of this Unit 2 is explain the importance of host data and network security. So in this, we have studied already how to secure the data and all. So these are all the objectives of this unit. So list the steps of securing the host, right? The host security, and define the application security and explain how to secure the data. So here, the first thing we are actually into it, right? So securing a host computer. So it's the thing we have studied in the last class. So what does mean by application data and host security? The basic security starts with protecting the host. You all know, right? So this is the basic security, protecting the host, application and the data. So these three things is very important, which is dealing with the information. So protecting the host, application and the data. So that is, if I am protecting the host, application and the data, then I am giving the basic security for that particular organization and all. So the basic security, which will starts with the protecting the host, application and data. So host, which can either be a server or a client on a network, runs application that process, saves or transport the data. So host may be a server or client. You all know, right? So host, definitely it would be a client or it would be a server. So which is present in a network, which is dealing with the data. So which will that server or the client which has its own applications and all, that application will process or save or transport the data. That is how they have been dealing with the data, the server and the client. So the host may be a server and the client, server or the client on a network, which runs an applications that will deal the data and all. So this is the basic security. If I am giving the basic security for a particular organization, then I have to start protecting the host, application and the data. So securing the host involves, so as I said earlier, the first step is actually protecting the physical device itself. So this is the thing we have seen in the last class, how we have been protecting the physical device. Even a cable lock, tying with your laptop will protect your device. Protect your laptop and all. Even if I'm having a CCTV camera in the corridor, that will monitor the intruder which is getting into my room and stealing my physical device and all. Right? Even a door, locking my door will prevent the intruder to prevent of stealing the devices, physical device and all. So we have studied a lot. So even a barrier will help us, even a man trap will help us, even a security guard will help us, right? Even an anti-climb procedure will help us to protect the physical device and all. So this is the things we have studied in the last class and all. So today in this class we are going to see securing the operating systems and using the anti-malware software. So this is the two topics we are going to see in this today's class. So let us get into the topic, securing the operating system. So securing the operating systems, you all know, right, what does mean by operating systems? We have been using different kinds of operating systems and all, right? So what are all the operating systems we have been using? Say for example, Windows, right? Windows 10 we have been currently using, right? So Windows 7 we have seen, right? So and in the Linux platform, Kali Linux we may use, Ubuntu we may use, Fedora we may use, right? So there are different versions of operating systems are there. So what are all the two approaches that has been used for securing the operating systems, right? So what are all the two approaches that has been used for securing the operating systems are properly configure the operating system after it has been installed to fortify it. So after the operating system has been installed, right, we have to properly configure the operating system. There are a lot of things are there to configure the operating systems. After it has been installed in your system, you can do a lot of configurations, right? Security configurations, right? So a lot of configurations are there. So I will show you some demo also at the end of this session. So group policy editor is there, which consists of number of configurations that will help us to configure the operating system that has to be performed in a secure way and all. So a lot of configurations are there that has to be configured after installing the operating system in your system. So that is the thing they have been seeing. That is the first approach, right? So that is the first approach. The second approach is actually tighten the security during the initial design and coding of the operating system. So that is the second approach. So during the coding of the operating systems or during the initial design of the operating system itself, we have to tighten the security. So this is the second approach. So there are only two approaches are there for securing the operating system. The first approach is after the operating system has been designed and it has been installed in your system, you can do some configurations that will help to secure your operating system. The second approach is during the initial design, during the creation of that particular operating system, during the coding of that particular operating system itself, you have to tighten the security in such a way that the code should be in such a way that it will secure after deploying that operating system. So that is the two different kinds of approaches that has been used for securing the operating systems and all. So there are actually 5 steps process of protecting the operating systems. The first step is develop the security policy. So every organization has its own security policies. We have to develop our own security policies. Perform the host software baseline. So this is a kind of checklist for every host. We have to define some checklist that every user that is handling that OS, particular OS and particular host, they have to follow that checklist. So that is actually perform the host software baseline. Third one is configuring the operating system security and settings. So as I said earlier, there are a lot of configurations are there. There are the OS security settings are there. So we have to do some configurations by our own so that we can secure the operating system. And then deploy the settings. So we can deploy or we can implement the settings so that we can secure the operating systems and all. And finally, the patch management procedures we have to follow. So implement the patch management procedure. So we will see one by one these 5 steps of step process for protecting the operating systems and all. So what are all the 5 steps? This is actually a very important topics that may be as an important question for your examinations and all. So for what is the first step? Consultatively we can have these 5 steps: develop the security policies, perform the host software baseline, and the third step is actually configure the operating system security and settings, deploy the settings, implement the patch management procedures. So what is the first and second step combinedly? We can have a look here. So security policies. So what is security policies? Documents that clearly define the organization defense mechanisms. As I said earlier, each and every organization, institutions, it has its own security policies. So that has been represented in the form of documents that will clearly define the organization defense mechanisms and all. So the second step here, what we have studied in the previous slide, is host software baseline. So as I said earlier, it is a standard or checklist against which the systems can be evaluated. So every system has its own checklist, right? So that based upon that checklist, that particular systems can be evaluated and all. So and then configuration settings that are used for each computer in the organizations, as I said earlier. So this is the first 2 steps we have studied in the previous slide. So security policies and software baselining. And the third step is nothing but the configuring the operating system security and settings. So as I said earlier, there are a number of configuration settings are there that will protect the operating system, that will secure the operating system in such a way that no one can get intrude, that will minimize to the intruders to get into the particular system and all. Hundreds of different security systems can be manipulated. So typical configuration baselines can be configured, right? So what are the configuration baseline? Changing the insecure default settings. So this is a very important thing. So initially, while we have an operating system installed in our system, it has its own insecure default settings. So we have to change. Definitely, we have to change this insecure default settings. So default settings we have to change. Say for example, in the browser, pop-up may be allowed. So there we have to block the pop-up, right? So say for example, any users can get into the systems. Authorizations has been given to any users who is being logging into your system. So that has to be changed. So everything is actually the default settings. We have to change the insecure default settings. The second step in configuration baseline is eliminating the unnecessary software services and protocols. Definitely, As I said earlier, the insecure, like the insecure default settings, we are having actually unnecessary software services and protocols are there. So we have to eliminate or we have to disable this thing. So that is also very important. So enabling the security features such as a firewall. So firewall, it has to be enabled in each and every system. That is actually mandatory. And we have to enable the real-time protection of Windows Defender also, right? So if you have been installing Microsoft Windows 10, then Windows Defender should be enabled. So for any versions of operating systems, firewall is actually common thing. So we have to enable this security features such as firewalls. And getting into the step 4. So what is the step 4? Deploy the settings through security template. So that is the step 4. So then the previous things we have to configure security settings. We have seen. And in the fourth steps we have to deploy the settings through the security template. So what is meant by security template here? It is actually the collections of security configuration settings. So as I said earlier, group policy is one of the very important and very known features of security template. So this is nothing but Windows features providing centralized computer management with the help of group policy management. You can do some centralized computer management with the help of group policy editor. So there is a group policy editor is there. I will show some demonstrations if possible at the end of this video. So group policy is nothing but the centralized computer management that will provide that will deploy the settings through a security template and all. A single configurations may be deployed to many users with the help of group policy. We can do a single configurations and can be deployed for many users. So this is the fourth step, deploying the security settings through security template. And in the fifth step, operating systems have increased in size and complexity. New attacks tools have made secure functions vulnerable, right? So during the evaluation of this operating system, right? So the size and the complexity is also being increased. So based upon this thing, number of attacking tools have been made to do some right. So number of attacking tools have been made secure functions vulnerable, right? So all the secure functions are there in the operating system itself. So these functions are becoming vulnerable with the help of these new attacking tools and all. So what we can do, how we can defend this vulnerability, right? Against this vulnerability and all, vulnerability based attacks and all. So the best thing is we can go for this security patch, right? General software update to cover the discovered vulnerabilities. So what is meant by security patch? It is nothing but the software update to cover up the discovered vulnerabilities. So you are having your update regularly for your operating system, right? So that is called actually security patch. So general software update to cover the discovered vulnerabilities. So if the vulnerabilities present in your system, if there is a loophole present in your system, right? So the vendor who is nothing but your Microsoft will send your update, and with that update, if you have been installing that update in your system, that will cover your vulnerabilities. That is actually what they are telling, to cover the discovered vulnerabilities. So that is actually security patch. And what is meant by hotfix here? Address a specific customer situation. So every specific situations will be addressed with the help of hotfix and all. So that is actually hotfix. It depends upon the customer satisfactions also. It depends upon specific applications also. What is meant by service pack? Actually, the service packs accumulates the security updates and additional features also that will enhance your operating system and all. So that is actually service pack. So if you have been gone through before 10 years back, everyone is using actually XP, right? So it is an operating system from Microsoft Windows. So here in this XP, while using it, it has been installed with the service packs and all. So service packs 1 is there, 2 is there, 3 is there, I think. So each and every service pack, if I am installing in my system along with the XP, it will enhance your operating system features and all. So that is actually service pack. So 3 things you have to do to cover the vulnerability in your system. The first one is security patch. This will cover the discovered vulnerabilities. Hotfix that will address the specific customer situation. Service pack that will give you additional features for your operating system. So modern operating systems can perform automatic updates, you know, right? So every system will ask an automatic updates if it is not a pirated version, if it is a genuine version. So every system will ask a update, automatic update. So through that notification, you can update your system and all. So OS interacting with the vendors online. So how it has been processed? So how this automatic update is happening in your system? It is a very simple procedure. OS interacts with the OS is actually interacting with the vendor, right? So simple vendor online update service, vendor online update service to automatically download the install patches depending upon the configuration option chosen. So simple. Communicating with the vendor's online update. So it is actually the server which is present in the vendor's side. So this is nothing but your host, and it is communicating with the vendor's online update. While they have been communicating, the update will be sent to your host and it has been installed. So simple thing. So OS interacting with the vendor's online update service to automatically download and install the patches, right? What are all the actually present updates it will install. Patches can sometimes create new problems, definitely. So it is actually very important while you've been installing your patches. Some systems with some configurations will not proceed with the new patches and all. So that will create a new problems and all. So vendors should thoroughly test before deploying it. So this testing is happening in any branded industries who is producing this operating system and all. So vendor is actually testing the OS before they have been deploying it into the host system. So they will test each and every update, security patches, hotfixes, right, service packs in their own systems before deploying to the host system through online. So it is being done. So to avoid these problems, the patches creating some problems, right? So to avoid these problems, vendor is actually do testing in their own systems with their own premises and before deploying this online patches. So there is a service called automated patch service, right? Automated patch service is there. So this manage patches locally instead using vendor's online update service. So what is the actual procedure here? Conventional procedure here. Your host system needs an update. It will communicate with the vendor's online update service, which is nothing but the server which is present in the vendor side. But here the automated patch update service is nothing but it has its patch server which is present in the locally. It is present which is present in the intra network, right? So within this server we can manage the patches locally instead of using the vendor's online update service. So what are all the advantages of using this automated patch update service? Administrators can approve or decline the updates for client systems, right? Administrators who is actually in charge of that particularly configured local automated patch service server, he can give an approval or he can give a decline updates for the client systems, or he can force updates to the install by specific date for a particular host system. And also he can obtain a report on what updates the particular computer or particular host needs. So this is a main advantage of having this automated patch update service within your local server, local network. So if I am installing a local server, right, server in my local network, then it is called actually automated patch update service. Administrators can approve the updates for detection only, allows them to see which computer will require update without actually installing it. So without installing a particular update in a system, we can allow them to see which computer will require a particular update. So let us see how it has been processing. Downloading the patches from the local server instead of using the vendor's online update service can save bandwidth definitely. So each and every systems in an organization, if it is they've been downloading an individual for their individual system, it is actually wasting their bandwidth and the time also, because each computer does not have to connect to the external server. So we can, without connecting this, doesn't need to connect it with the external server, we can definitely save the bandwidth and the time. Specific type of updates that the organization does not test, the hot fixes for example, can be automatically installed whenever they become available. So users cannot disable any updates as they can if computer configured to the user vendor's online update services. So the client themselves couldn't disable or circumvent the updates as they can if a computer is configured to use the Windows online update service. So how it has been using. So this is a structure for automated update service. So it's a very simple architecture, right? So this is an internet. So how conventional operating system has been updating is nothing but if I'm having this system, it is communicating with the server through internet. It will download the install and it has been installing. So very simple method. So during these installations, some patches may create a problem for this particular host, right? It may cause, as I said earlier. So, and also if I'm having some several system in my organization, say for example 100 system in my organization, every system should communicate to the vendor's online update server through the internet, and it has to download all the patches and update towards its host, and it has to be installed. So I am wasting my time for each and every system to download the automatic update, the updates and the patches, and also I am wasting here the bandwidth also. So to avoid this individually updating the system in an organization, I am using a patch server, right? So this is called actually automated patch update server. So what I am doing here is with the help of this automated patch update server, I am dumping my updates in a local server which is present in the local area network. And after dumping here, I may use a system to install and test whether it is been creating any problem and all. Right, for my topology, if it is been creating some problem and all, then I can avoid that particular patch and all. If it is not creating any problem, if it is really needed for my network, for my system, then I can pass it to the next system to install the operating system patches. So similarly, I can have a secondary automated patch server also, from where I can fetch the details of the updates from the primary server, and I can do installation in different host machines. So this is called actually automated patch update service. So automated patch update service is a very important procedure, right? So that has been used for implementing, installing the automatic updates and patches and security fixes to the systems locally instead of directly communicating the vendor's online update service. So the second approach, so this is the steps. So far we have studied a number of steps that has been used for securing the operating systems after the operating system has been created and after it has been installed in a particular system. Now we are going to see the second approach, which is nothing but the security through design. So through other techniques used instead of managing the different security options of an operating system that has been already deployed is nothing but OS hardening. What is meant by OS hardening here? Necessary to tighten the security during the design and coding of the OS. So if I want to secure a particular operating systems, I have to do during the design itself. So I have to tighten the security during the design and coding of the operating system itself. So what is meant by trusted OS here? So operating system that has been designed through OS hardening is called actually trusted OS. So what is meant by OS hardening here? It is nothing but tighten the security during the design and coding of the OS itself. So that is called actually OS hardening. If I am using an operating system that has been already having the security, tightened the security during the design and the coding, then that is called actually trusted OS. So different techniques are there for OS hardening. can give a least privileges, reduce the capabilities, read-only file systems, and kernel pruning. Kernel pruning is a very important concept. It will remove all the unnecessary features that may compromise an operating system. So that is called actually kernel pruning. So removing all the unnecessary features that has been creating or compromising some compromising a particular operating system. What does it mean by read-only file systems? I can do some modifications in the file access. Important operating system files cannot be changed. I can give some privileges for a particular file. I can give some authorization, security for some particular files. Reduce capabilities. Significantly restricts what resources can be accessed and by who, right? So this is actually reducing the capabilities. Least privileges. Remove all the supervisor and administrative accounts, and we can split the privileges into smaller units to provide the least privileges into a user or process. So that is actually providing the least privileges and all. So these are all the techniques that has been used in OS hardening, and this has to be, this kind of techniques has to be deployed while creating my OS. So that is very, very important. While creating my OS itself, I have to do this deployment and all. While designing my OS, while coding my OS itself, I have to do this hardening technique and all, so that it can be a trusted OS. So the next topic is securing with the anti-malware, right? Operating systems software continued to add security protections to core set of features. Definitely every operating systems will add a security protection which is having some core set of features and all. Instead of this also, adding to this security features, security protections also, we are having a third-party anti-malware software. It is nothing but the software package that can provide a added security, right? You can name some third-party anti-malware softwares and all. There are number of anti-malware softwares and all. Say for example, Symantec is there, producing Norton antivirus, right? Kaspersky is there, McAfee is there, K7 antivirus is there, Quick Heal is there, Bitdefender is there, Avira is there, Avast is there. So number of Spysweeper is there, number of third-party anti-malware softwares are there that has been used for giving an added security for a particular operating system. So anti-malware softwares may be a categorization of antivirus. It will do protection against a virus, right? Antispam, do protection against the spam, right? Pop-up blockers and anti-spyware is there, right? Host-based firewalls are also there. So these are all some categories of anti-malware. So what is meant by, we can see one by one, what is meant by antivirus. So this is actually the software that examines the computer for the infections, right? So it will examine the computer frequently against some infections and all. It is actually a software. Antivirus is nothing but a software. Static analysis is being used in this antivirus. If I am using a static analysis for protecting the files in my system, to protecting or examining the computer against the infection, so which is nothing but the static analysis scans the files by attempting to match the known virus pattern against a potentially infected file. So it will match with the known virus patterns. So keep it in your mind. So that it will scan the files. So I am having this, the system is having number of files. So each files will be scanned based upon the matches to the known virus patterns. If this file is having some virus pattern, then I have to do a quarantine of this file. So this is called actually static analysis. Host AV, it is a software contains a virus scanning engine and a database of known virus signatures. So static analysis, it doesn't have any databases and all. So what it will do a scan for each and every file. Every file in the system, it will do a scanning, and if a file is having some code which is related to do some unusual activities, say for example unethical activities, illegal activities, it has, if it has its own code, that code will be detected and that file will be quarantined in the static analysis. But in case of host antivirus, it is a software contains a virus scan engine. A scan engine will be there, similar to the static analysis. Each and every file will be scanned, and there is a database, backend database there in the host AV. right? This database will consist of the signatures, signature 1, signature 2, right, signature 3. So it will do a mapping with the files which is present in the system. So if any file, if any infected file is matching with any signatures, that particular file will be quarantined. So this is present, this is happening in the host AV. So what it will do, so it will do a scan of each and every file. If any infectious file is present there, if I am having the corresponding signature in my database, then that particular infectious file will be quarantined. So that is actually host AV. By comparing the virus signatures against a potentially infected file, what I said earlier, match may indicate the infected file. So that is actually host AV. So antivirus scanning, there are different kinds of antivirus scannings are there. Wildcard scanning is there, mismatch scanning is there. What does it mean by wildcard scanning? It is allowed to skip bytes, so or ranges of bytes. So it will skip the files which is having some ranges of bytes instead of looking for an exact match. So that is actually wildcard. Mismatch scanning is mismatches allows a set number of bytes in the string to be any value regardless of their position in the string. So regardless of the position of the string, it will do a scanning. So weakness of the static analysis. What is the weakness of the static analysis? It's nothing but, so this is a very important 2-mark question. Weakness of the static analysis is the AV vendor must constantly be searching there for new viruses, right? So if I am doing this static analysis post AV procedure in my system, then how my signature is being created, S1, S2, S3 signature is being created. So it should match a particular infections, right? So that infections has to be already have to be researched in a particular lab and all. So that is what they have been saying. So where this research is happening in the AV vendor office and all. So is the weakness of a particular static analysis is AV vendor must constantly be searching the new viruses, extracting the virus signature. So I have to, if there is a virus V1 is there, I have to extract the signature, say for example S1. This has to be feed in the database and it has to be checked with the file, each and every file while doing the scanning and all. So this is the process happening in the post AV of static analysis procedure. For new viruses, I have to search for the new viruses, extracting the virus signatures and distributing those updated databases to all the users. So this is the weakness of the static analysis. So initially what I have to do, I have to do a research in my research lab, say for example Symantec, say for example a McAfee, say for example a K7 antivirus. They have to do some research of a particular virus. I have to find a new virus and grabbing that particular virus, I have to create a signature for that particular virus and I have to feed that signature into the host database, right? And in the particular host machine, the scan engine will scan all the files which is present in the system, and if any infections is present, and based upon the signature, I am going to remove this or quarantine this particular infectious file. So this is happening in the static analysis of host AV. This is also a weakness. So I have to find a new virus every time, right? If I am missing any virus, that will lead a very big problem in a particular system and all. So antivirus detection, another kind of detection is a dynamic heuristic detection. It uses a variety of techniques to spot the characteristics of virus instead of attempting to make matches, right? Instead of doing some mapping with the signature and the infectious files, I am here spotting the characteristics of virus. So if a virus is doing something, if it is illegally communicating, if any IP address, right? So that IP address is actually a malicious IP address. I have to check that particular IP address is malicious or not, right? So if it is communicating a malicious IP address, a particular file, so then it is actually a malware. So I am here spotting the characteristics of the virus, right? So if it is downloading some anonymous file without any user knowledge, then it is actually an illegal activity. So I am spotting the characteristics of the virus. Right? Code emulation. What is meant by code emulation here? It is nothing but the virtual environment is created that simulates the central processing unit and memory of the computer. Any questionable program code is executed in that particular virtual environment to determine if it is a virus or not. So there will be no actual virus code is executed in your real CPU, That is called actually code emulation. Have you heard about sandbox? Sandbox is there, right? You search in the internet sandbox. So sandbox is nothing but your code emulations. That is actually a virtual environment that will create a virtual environment for executing a particular suspicious file, right? So that will get executed in that particular virtual environment. That environment has its own CPU, right, and memory of a particular computer. It has all the capabilities, all the eligibility of for a particular malicious file to be get executed. So that is actually sandbox. No virus will be, actual virus will be executed in your real CPU, real laptop and real system. Will get executed in the virtual environment. That is actually code emulation. So anti-spam, you heard about anti-spam. Anti-spam is nothing but spammers can distribute a malware through email attachments are used for social engineering attacks. So spammers, you know, right? So you will be getting number of spam mails, right? So while opening that mail, it has been asked to click a particular attachments during via that particular attachment, many malicious softwares can be installed in your system. So Bayesian filtering is actually normally generally used for analyzing every word in each spam and determines how frequently a word occurs in a spam while compared to the not spam file. Right, so this is actually a Bayesian filtering. It is a common filtering approach, a technique that has been analyzing each and every mail. Right, what are all the words which is present in the particular mail. Based upon that words and the sentences, it will filter the particular mail to a spam folder. So creating a list of senders. So blacklist, whitelist. So this is also a very important 2-mark question. A blacklist or whitelist. Blacklist allows the everything is unless it appears on the list. Whitelist, a list of approved senders, right? So that is actually whitelist. So blacklist allows everything in unless it appears on the list. Whitelist is nothing but a list of approved senders. So whitelist I can trust. Blacklist I couldn't trust a particular element which is present in that blacklist. Say for example, if I am having a set of IP address which is actually a malicious IP address, right? That should be present in the blacklist, right? So I couldn't follow that IP address because it will do some malicious activities. Whitelist means, right, say for example www.google.com. So that is actually a Google website, so which will be present in the whitelist. So it is actually a legal one. So if anything present illegal, that has to be uploaded in the blacklist. So pop-up blocker. Pop-up small windows appearing over a web page usually created by the advertisers. So you all know, right, pop-up blocking. Every time if you have been visiting some websites, right, so a pop-up will be blocked and a pop-up will be evolved, right, so that will do some anonymous activities and all. Pop-up blocker separate the program as a part of anti-spyware package incorporated within the browser that allows the users to limit or block most of the pop-ups. So pop-up blocker, as I said, it is a security settings. So it is a separate program, we can say, as a part of anti-spyware package incorporated within the browser itself that allows the users to limit or block most of the pop-ups. It can used to alert, can be displayed in the browsers and gives users options to display the pop-ups and all. So you all know what is meant by pop-up blocker. You have been actually experiencing with this pop-ups and pop-up blockers. So host-based application firewall. A firewall, we can call it as a packet filtering, designed to prevent the malicious packets entering and leaving. So any packets which is entering into your system, right, it has to be monitored, and it has to be inspected whether any malicious content is present in that particular packet or not. So that is actually the important behavior of the firewall. So in a network, while crossing the network and entering into your system, every packet has to be monitored and inspected for a malicious content. Maybe a hardware or a software based firewall. right? So host-based application firewall, a software firewall runs on a local system is nothing but a host-based application firewall. If I am having a dedicated system, then that is called actually a hardware firewall, right? If I am having a software which is installed in my local system, then that is called actually software-based firewall. Application running on a host computer may need a send and receive transmission that normally would be blocked by a firewall. So if it is an anonymous packet which is transmitting over the network, then it has to be stopped. So that is the important behavior of the firewall that has been used to block malicious packet and all. Opening the firewall can be created by the user simply by approving the applications. So this is the configurations, usual configurations happening in the firewall. Securing the static environments. What are all the devices which is present, or any host system which is present in the static environments? This number of devices with the microprocessors grows through this becoming the target. Say for example, static environment devices. It is the types of devices with a microprocessor not designed to be updated. So if I'm having a tiny machine, say for example, it has been built with a microprocessor, so we couldn't give a continuous update for that operating system which is being installed on that microprocessor. So that system is called actually static environment devices. The static environment devices, it is a type of devices with a microprocessor that has been not designed to be updated. We can call here an embedded system also. It is a computer systems with the dedicated functions within a larger electrical or mechanical systems. Within a larger electrical or mechanical systems, it is actually a dedicated, it will do some, it is actually a device that will do some dedicated functions, right, to do some particular activity, specific activity. So OS often stripped down versions of general purpose operating systems and may contain many of some vulnerabilities. So number of vulnerabilities or open vulnerabilities are there in the static environment devices. So static environment devices is nothing but we can call it as a microprocessor devices where I couldn't update my OS, or we can call it as an embedded devices, right, which will do some specific activities. So what are all the other devices? Consoles, smartphones, and mainframes. Gaming consoles. Many consumers game consoles contains adaptation of general purpose operating systems. So we have been using open operating systems and all, and may contain some of the same vulnerabilities, right? So that is the drawback of gaming consoles. Smartphones, as I said earlier, it includes an operating system that allows you to run a third-party applications. We have been downloading number of APK files from the third-party applications, third-party websites, and have been installing some applications and all. So that will cause some problem in our operating system. But operating systems have the vulnerabilities that attackers can exploit. Mainframe, very large computing systems that have a significant processing capabilities is called actually mainframe. You all know, right, what is meant by mainframe. So every system has its own vulnerability, right? Say for example, in smartphone, right, we have been running number of third-party applications that will exploit number of vulnerabilities and all. So automobile and SCADA, right? In vehicle computer system, automobile functions that are controlled by the microprocessors, you know, right? So SCADA, which is nothing but a supervisory control and data acquisition element, large scale industrial control systems found in military installation, oil pipeline control system, manufacturing environments, and nuclear power plants. So it has its own vulnerability that has been exploited periodically. So automobile and SCADA. So what are all the static environment defense methods we can give? So far we have studied static environment, SCADA, right? Vehicle automated vehicle devices. So everything are called actually static environmental devices. So what are all the defense mechanisms we can give for these static environmental devices? Or network segmentations. Keep devices on their own network separated from the regular. So that is a very important thing. We have to keep the devices in their own network, separated from the regular network. This will avoid a number of attacks. This is a very important defense mechanisms nowadays. Any industries is actually following this method. security layers, build security layers around the devices. We can do this thing. Application firewalls, when it is feasible, install application firewalls on the device operating systems. We can do this thing. Manual updates, provide a means of manual software updates when automated updates cannot be used. So if I am not able to update the particular static environmental device, say for example a microprocessor or for example an embedded devices, I can do an update, manual update also. Firmware version control, develop a policy that keeps tracks of the updates of the firmware. So I have to develop a policy to check the updates in the firmware, in the OS. Control redundancy and diversity. Keep the operating system's code as basic as possible to limit the overlapping of unnecessary features. So this is also a defense method we can use. Right. And finally, the application security. Along with the securing the operating system software on the host and in the static environment, so operating system in the host, operating system software on the host and the static environment, say for example embedded devices or smartphones, is equally need to protect the application that runs on the devices. So what we have seen so far, securing the operating system on the host, securing the operating system on the static environment. Static environment is nothing but the embedded devices, right? In vehicle, automated vehicles, SCADA, everything is called actually static environment, right? So we have to, in addition to that securing concept, we have to secure the applications also. What is application security? Application development security, application hardening and patch management. We'll see one by one. What is meant by application development security? Security for the applications must be considered through all the phases of development cycle. So if I am developing a particular software, it has to enter into the development cycle and it has to come out from the development cycle. So security for the applications should be considered through all the phases of the different phases of development cycle. Application configuration baselines. So what are all the baselines for basic thing we have to follow? Standard environmental settings can be established. A secure baseline includes each development system, build the system and test the system. Must include a system and the network configuration. So these are all the application configuration baselines. Standard environment settings, right, can be established to secure a baseline. Establishes a secure baseline. Includes each development system, a build system and a test system. So we have to do we have to give a security at every phases at a development system, build system and the test system. Must include a system and a network configurations. Secure coding concept is a very important concept in application security. So coding standards increase the application's consistency, reliability and security. Coding standards useful in code review processes, right? So while coding a particular application itself, as I said earlier in the operating system, while coding itself, we can create a trusted OS. Similarly, while coding an operating application itself, we can create a very good application. We can secure the particular application. So what is meant by wrapper function here? Used to write a error checking routines for a pre-existing system function. So your software is nothing but a line of codes, right? So I have to check, right, for every functions I have to write a routine that will check the error. So that is the thing they have been telling here in the wrapper function. Used to write error checking routines for the pre-existing system functions. So wrapper function is a substitute for a regular functions that is being used in the testing. Okay, so that is actually a wrapper function. For every functions I have to write a error checking routines. Exceptions. In application security, exception is a very important thing. Faults that occur while application is running. So if any application is running, if it is creating any error and all, then that is called actually fault or error. Response should be based on the error. The response should be actually based on the particular error, right? So improper handling can lead to the application failure or insecurity. So while handling a particular application, if I am into some improper handling of a particular application, that will lead to a application failure. So we can go for a fuzzy testing, so software testing technique that deliberately provides invalid, unexpected or random data as inputs to the computer program. So the testing procedure can be incorporated right after developing a particular software that will deliberately provide an invalid, unexpected, random data as an input to a particular applications what we have created. Error handling. Error handling practices to avoid failing to check return codes or handling exceptions or improperly checking them. Handling all the return codes or exceptions in the same manner. Divulging the potentially sensitive data in error informations. So this is called actually error handling. So we can handle the error with the help of check return codes, right? Or we can write a handling exceptions. Handling all the return codes or the exceptions in the same manner, divulging the potentially sensitive data in error informations. So we have to do some input validation also while we have been giving this application security. Verify the user's response to the applications. What we have studied in different application-based attacks, right? SQL injection attack, XSS attack. So every attack, how it has been occurring? It has been occurring because of the lack of input validation. So we have to check on the input validation also. So could cause a program to abort. So cross-site request forgery attacks uses the user's web browser settings to impersonate like a particular user. So input validation, as I said earlier, verifies the user's input to an application and it is performed after data entered but before the destination is known. So that is actually input validation. So server and client-side validation has to be done to avoid this, to defend against, or to avoid or to prevent the application-based attacks and all. So input validation generally uses the server to perform the validation. Client-side validation, client have to perform the validation. So we can use some SQL alternatives instead of using an SQL databases. Right, it has been usually conventional SQL relational databases are being used. To avoid this SQL injections, we can use a SQL relational database altogether. No SQL is there. New and non-relational databases is there. No SQL databases with the SQL database. Argument over the database technology is better. So we can use no SQL database and all. So application attacks, application hardening intended to prevent the exploit the vulnerabilities. So hardening an application definitely prevent exploiting the vulnerabilities. So we can go for similarly as we talked in OS patch management. Here we can use an application patch management also. But it is actually rare until recently. Application patch management, users unaware of existence of patches or update of a particular applications have where to occur them. So it is actually lack of knowledge of every users for getting the updates from a particular where we have to get, where I have to trust a particular resource to get the patches and all. So more application patch management systems are being developed today, right? So attacks based on the application vulnerabilities. Some of the attacks before entering into the application patch management, we'll see some attack based on the application. Executable file attacks, system tampering is also there. Process spawning control is also there. What is mean by process spawning control? Tick the vulnerable applications into spawning executable files into the system is called actually process spawning control. Finally, how we can secure the data. If I want to secure the data, right, work today involves electronic collaboration, so data must flow freely but securely. So data should flow freely and securely. That is my ultimate objective here while securing the data. So we can use a DLP, data loss prevention system. It is a system of security tools used to recognize and identify a critical data and ensure it is protected. Right, so it is actually a set of tools, security tools used in recognizing, monitoring or identifying the critical data and ensure whether that particular data is protected or not. Goal is to protect the data. So there are three kinds of data: data in use, data in transit and data at rest. What is meant by data in use? Data actions being performed by the endpoint devices. So that is actually data in use. Say for example, if I am having a laptop, if I am using some processing some Word document, means that is actually data in use. What is meant by data in transit? Actions that transmits the data across a network. If I am sending the same Word document to my friend, so it has to pass through the network. So that is actually data in transmit. What is meant by data at rest? Stored on the electronic. If I am saving the particular data in my USB drive, then that is called actually data at rest. So what is meant by DLP techniques? It is actually the content inspection process, the security analysis of the transaction, and it takes context into account. DLP systems also can use the index matching. So that is actually content inspection. Document identified as needing protection, such as the program source code for a new software applications. If I am saving some coding part of my software application, that has to be protected. So I have to identify the needed protection for a particular document and all, which is being analyzed by the DLP system. Complex computations are conducted based on the analysis. So it consists of DLP system, consists of different sensors. DLP network sensor that will sense the data in transit, storage sensor that will sense the data at rest, and DLP agent sensors are installed on each host devices, say for example desktop, laptop, tablet, and protect the data in use. So this is the architecture of the DLP, right? So DLP agent is installed in a particular desktop so that I can protect the data in use. Similarly, I can use a DLP storage sensor where I can protect the data which is actually present in data at rest. If I am transmitting a data towards the network, then I can use a DLP network sensor that will protect the data at transit, right? So this is the simple DLP architecture. So DLP data loss prevention architecture is nothing but it is being having a set of security tools which is being installed at several systems that has been used to protect data in rest, data in use, and the data in transmit. That is the thing. Okay, so this is an example for DLP report that will deliberate some of the information of the data.